Live.
Well, hello everyone. It's great to welcome you to today's webinar. Actually, this is the 10th session we have broadcast since July of last year. And we've had a succession of really excellent, thought-provoking talks from leading thinkers in a variety of areas, including virology, aspects of biology, often sweeping back to a consideration of how things came to be the way they are. We've had such significant names as Steve Meyer, and we'll have Steve again next month talking about his new book. We've had Doug Axe, Paul Nelson, Mike Behe, Jim Tour, Gunter Bechley. David Williams will be moderating the Q&A session this evening. And last month we had Casey Luskin. And you'll find links to all of these recorded sessions on our website. And if you haven't already visited the website, then you'll find it right here at C4ID, and if you just Google that, then you'll get it. And you'll see right there on the homepage, there's a link right there to the various webinars that we've already transmitted. In addition to that, there's a YouTube channel that you've tuned into this evening. And in that regard, can I just remind you that we will have some Q&A this evening, and so be ready with your questions, and you can put them in the YouTube chat, and David will be monitoring that, and he will help to process these after our talk this evening. Now, today, I would say we have a particularly special guest. We have Dr. Michael Denton. And it was Mike's book, Evolution, A Theory in Crisis, that originally appeared in the mid-80s, that really helped to focus the thinking of a number of significant contributors to the concept of design in nature, including people like Philip Johnson and Mike Behe, whom we've mentioned already. And the essence of his argument in that book still essentially holds today, and that is that on close inspection, much of the complexity of the biological world cannot be accounted for in terms of gradual cumulative selection. And Mike has produced many additional books picking up specific aspects of fitness and fine-tuning in nature, and each of these has added evidence to the reality of teleology in chemistry and in biological disciplines and beyond. And so we're really delighted to welcome Mike. Mike is originally from the northeast of England. You'll detect his wonderfully preserved northeast accent in just a moment. His initial training was in medicine at the University of Bristol. He did his doctoral studies and postdoc research into genetic aspects of retinal diseases at King's College. Indeed, was responsible for leading the first trial of gene therapy for retinal disease at Moorfields, the specialist eye hospital in London. He's written extensively on different aspects of the topic that he's going to consider tonight, and I'm sure you'll find his talk today on the Primal Blueprint absolutely fascinating. Now, Mike is grappling with the technology, and he's going to share his screen in just a moment, but do bear in mind that it is 2:30 a.m. in Perth, Australia, which is where he's speaking from. And Mike, can I just say, we really appreciate the fact that you've agreed to forego sleep at this point to bring us this lecture. So let me welcome you and hand over to you at this point for your talk on the Primal Blueprint. Thank you very much indeed.
So here I go, share screen. Got my share. That's it. Okay.
Yep, good.
So we're ready to go.
Good.
So today's talk is going to be mainly about biological fitness, the fitness of nature for carbon-based life, and particularly for beings like ourselves. But before I get onto the main topic, I just want to say that, in fact, I've had three major areas of interest in the general sort of ID, anti-Darwinian sort of area. First of all, my first book was Evolution, Theory in Crisis, which was in fact a critique, basically a critique of Darwinism. The second book, Nature's Destiny, was in fact about nature's fitness for carbon-based life as it exists on Earth and beings like ourselves. And the third book, which is an update of my first book, is a defense of structuralist ideas in biology. Well, first of all, I'm going to say a few words about how I wrote Evolution, and then how I got to write Nature's Destiny. My journey to skepticism regarding Darwinism began while studying the development of the red blood cell at King's College in London for my PhD. And one of the fascinating things about erythroid development is that at the end of the process, the nucleus is extruded from the developing erythrocyte, leaving an enucleate cell, the classic biconcave erythrocyte shown here in the figure. And what is, of course, what struck me as being very strange about the process was that it seemed to be an offense to classic Darwinian claims. Darwin claimed that natura non facit saltum, nature doesn't take jumps. But here I was faced with, in the the topic of my PhD study, here was a classic jump where the nucleus of a cell is extruded from the cell. And it's actually a very complicated process which utilizes a good deal of the cytological machinery inside the cell. It's not just something simple like an increase in hemoglobin density in the cell, which sort of eventually extrudes the nucleus by simple pressure. No, it's a complex process. And it's perhaps something like an unequal cell division. But the challenge to Darwinism is that the whole process, finding out whether in fact the nucleus is beneficial outside the cell can't be done until it's gone outside the cell, and the whole process takes about 20 minutes during current erythropoiesis. So it struck me that in fact here you have a case which seems to be totally incompatible with the Darwinian claim that complex novelties in nature can come about by a whole series of little adaptive steps. This struck me as being quite impossible. There's no way I could explain it, and nobody else in corridor talk or tea room talk at King's could also explain it. So I felt that this was in fact a very intriguing event in biology, and I was wondering whether in fact there might be more phenomena like this. At that stage, I wasn't really a committed anti-Darwinist, but the seeds of doubt were being sown. And over the next 10 years, from finishing my PhD at King's and experiencing the weird phenomena of enucleation of the cell, I looked around into the biological world and found that there were lots and lots of different phenomena, novelties in nature, which were also not led up to by a series of small intermediate steps, including the classic Michael Behe's classic bacterial flagellum, the nematocysts of jellyfish, mammalian hair, or the inverted retina of the vertebrates. In none of these sorts of things, and there wasn't just these four, I mean, there were thousands, all nature was permeated by these sorts of things. I found that, in fact, there was a vast number of things that you can't explain in terms of little Darwinian steps. And what was even more extraordinary is, as I examined the way that classification works, I found that the defining novelties of most groups of animals were not led up to at all by any intermediate things. And so you could actually, because different groups possess these defining novelties which are not led up to, then you can classify all organisms extant and extinct into very distinct groups of organisms, which created an overall picture which seemed nothing like the Darwinian worldview. For example, if you take vertebrates, you can look at the all vertebrates possess vertebrae, and no other groups of organisms possess anything like vertebrae. Or you can come to the higher vertebrates, which are the amniotes. All of them possess an amniotic egg, and that is that the embryo is enclosed in fluid, which is bounded by the amniotic membrane. And that system, that adaptation is not led up to by any other organism. So you can put all the higher vertebrates into the class Amniota unambiguously, and just as you can put all vertebrates into the class Vertebrate unambiguously. As I say, I was surprised that in fact the fact that you can classify everything by these novelties which are not led up to, and the fact that you can classify things into very distinct groups, struck me as being a very striking fact, which didn't fit with the Darwinian pattern at all. And I was surprised to find that while I was musing on these issues myself, there was a challenge posed by the existence of unique defining novelties to Darwinism, which was highlighted by cladistic taxonomists between the 70s and the 90s. And one of the radical cladists was a guy called Colin Patterson, who was working at the Natural History Museum in London, in South Kensington. And I've got two quotes of his here, and you can see how radical they are. He said, as the theory of cladistics has developed, it has been realized that more and more of the evolutionary framework is inessential and may be dropped. Even more radical was his statement, much of today's explanation of nature in terms of neo-Darwinism or the synthetic theory may be empty rhetoric. As far as ancestors are concerned, they exist not in nature, but in the mind of the taxonomist as abstractions, but they are discussed as if they have some reality. Well, here were first-class biologists at a leading biological institution making statements which looked extremely critical of Darwinism. And for the same reason that I'd sort of turned up myself. In fact, you define groups by these unique novelties, and they're not led up to. So you have very distinct groups. And I was just quite staggered that at two institutions, I eventually met Colin Patterson, Gareth Nelson, and Owen Platting. But at the two major biological institutions, the Natural History Museum in South Kensington and the American Museum of Natural History, there were leading authors that stressed that classification systems show that species are always and only related to each other as sister groups, and that there are no empirically known ancestor-descendant sequences in nature. Well, it was amazing to think that these sorts of noises, these sorts of claims were being made at these two major institutions. And naturally, nature, on the challenge of classification, cladism railed against the cladists and what was going on in South Kensington and at the American Museum of Natural History. So basically, it was my own discovery of doing my PhD of the enucleation of the cell, the difficulty of explaining that in terms of Darwinian gradualism, my realization that that phenomena was not restricted to the development of the red cell, but was all over nature. And that led to classification schemes which simply didn't fit the Darwinian model of nature at all. And then finding that, in fact, here were top authors in leading institutions which were making the same sorts of noises. Then I sat down and worked on the next 10 years to produce Evolution, a Theory in Crisis. And as I said in the preface, I said in this book, by presenting a systematic critique of the current Darwinian model, ranging from paleontology to molecular biology, I've tried to show why I believe that the problems are too severe to offer any hope of resolution in terms of the orthodox Darwinian framework. So that's how these are some of the steps and some of the thought processes, some of the sort of intellectual discovery which led to Evolution, a Theory in Crisis. And I found it very satisfying putting it all into that manuscript. Now, already I'm talking too much and I'm getting out of time. So how did I get into fitness? Well, that occurred because of a meeting with somebody at the 9th Human Gene Mapping Conference in Paris. The guy's name was Marcel Schutzenberger, who is a brilliant polymath, member of the French Academy of Science and the leading anti-Darwinist in France. And in many conversations in his apartment off the Rue de Ranelagh beside the Bois de Boulogne in Paris, he mentioned a book called The Fitness of the Environment by Lawrence Henderson. And he sort of told me I should read it. Well, he sort of basically commanded me to read it. And he made me a photocopy of the book. And he told me, read it when you fly back from Charles de Gaulle to Sydney. Henderson, of course, every medic knows that this is the Henderson-Hasselbalch equation, the equation that all medics learn about and probably never come to terms with fully, though. So this is Lawrence Henderson's The Fitness of the Environment. As I was reading the book on the plane, I was amazed at what I was reading. Here are some quotes from the book. Henderson says, hence it may be concluded that hydrogen, oxygen, and carbon, water and carbonic acid, are not to be rivaled in their own qualities. We may conclude that the fitness of water, carbonic acid, and the three elements, hydrogen, oxygen, and carbon, make up a unique ensemble for the organic mechanism. And the last sentence in the book is, the whole evolutionary process, both cosmically and organic, is one. And the biologist may now rightly regard the universe in its very essence as biocentric. And I found that, you know, found this wonderful stuff. This is a full discovery for me. I'd never considered this area of fitness before. But what really struck me about Henderson was he hints in many places in this classic book that it's not just the fitness of water, carbon dioxide, for carbon-based life. It's a fitness for beings like ourselves. For instance, about the gaseous nature of CO2, which I will talk about a bit later, of course. He says, in the course of a day, a man of average size produces nearly 2 pounds of carbon dioxide. All this must be rapidly removed from the body. And then he goes on to say at the end, I won't read the whole quote out, but he says, were carbon dioxide not gaseous, its excretion would be the greatest of physiological tasks. And so basically, he's talking here about human biology, the fitness of a particular fact that at the end of oxidative metabolism, one of the waste products, CO2, is a gas and can be excreted from the body relatively easily. So this looks like an element of fitness for our sort of physiological being. And then he goes on again, and he says an adult, and he's talking about an adult human weighing 75 kilograms, produces daily 2,400 great calories, which is an amount of heat sufficient to raise the temperature of his body by more than 32 degrees centigrade. If the heat capacity of his body corresponded to that of most substances, the same quantity of heat would be sufficient to raise his body temperature between 100 and 150 degrees. So what was very exciting about the fitness and what transfixed me on that plane, it was a book I picked up. I read the first page, and it's literally, I couldn't put it down. I realized here was somebody who was saying that in fact nature seemed to be fine-tuned for beings like ourselves. And I was well aware, of course, of the cosmic fine-tuning arguments of the cosmologists, which also came out roughly at the same time when I was musing on these things in the 70s and 80s. There was Hoyle's famous statement, and I'm sure many people in the audience will have read this themselves. If you wanted to produce carbon and oxygen in roughly equal quantities by stellar nucleosynthesis, you'd have to fix certain things exactly as they are. And he suggested that a super intellect had monkeyed with physics as well as chemistry and biology, and that there were no blind forces worth speaking about in nature. And I was also aware of Davis's accidental universe. And he's making the same point, that it looks as if the universe is fine-tuned for stable planetary systems, for stars, and so forth. But what was missing in Hoyle and also in Davis and many of the cosmologists who were arguing for fine-tuning was man's place in nature. Because it seemed to me that in fact, these are very powerful arguments for the possibility of a divine mind fine-tuning the universe. It wasn't clear from this cosmological evidence that it was fine-tuned for beings of our biology. And this was significant because if just for a quick historical reminder, to consider for a moment the pre-Copernican medieval worldview. There's a beautiful book by Gurevich on the categories of medieval culture. And I've taken these quotes from his book, actually. And it's the medievalists attempted to see the world as a single unified whole. And this theme runs through all the medieval, some of the encyclopedias, the entomologies, the philosophies of the 12th century. And this is beautiful, I think. Speak of the necessity of studying nature, for in the cognition of nature in all her depths, man finds himself. That's a beautiful phrase. And I've copied that phrase in many of my subsequent publications. The unity of man with the universe is revealed in the harmony interpenetrating them. Both man and the world are governed by the cosmic coincidences which express the harmony of the whole and its parts which permeate all from the heavenly spheres to man. And amazingly, each part of the human body, according to the medieval scholars, corresponded to a part of the universe, the head to the skies, the breath. Anyway, basically, they looked upon the universe as a holistic system, which was designed especially around man's existence. And this was, of course, one of the bedrock, the fundamental axioms of the high noon of medieval Western Christianity, that man was the center of things and everything had been made for man. Well, that argument was certainly missing in the views of the cosmologists, but it was there emerging again in Henderson's fitness. What happened in the 16th century was the medieval view, people say, well, you know, the Copernican revolution discovered the universe was huge and infinite and things like that. But the real problem was that connection between man and cosmos, between biology and cosmology, was broken at the beginning of the scientific revolution. And I like these two illustrations. One's from Copernicus's De Revolutionibus, showing the beautiful circular motions of the well, of course we know they're elliptical now, but he pictured them as circular, compared with this beautiful thing from De Fabrica, an early anatomical text, which shows the blood vessels in the human body. There's no connection between these two things anymore. You can't imagine that there's any connection whatsoever. They seem to be completely different things. So the Copernican model of the solar system, shown alongside a 16th century depiction of blood vessels in the human body, shows the disconnect. And interestingly, both these revolutionary books were published in the same year, in 1543. The Fabrica providing the first time an accurate portrayal of the heart, lungs, and circulatory system, and so forth, not based on dissections. And when the body was examined, those medieval connections with the cosmos simply didn't exist. So the post-Copernicus disconnect meant that man had lost his place in the universe and lost the very world in which he was living. The poet John Donne lamented, "'Tis all in pieces, all coherence gone." So that's what excited me about Henderson's fitness, and I decided to write, as it were, an update of Henderson's fitness. And in the beginning of this book, I say the aim of this book is to first present scientific evidence for believing that the cosmos is uniquely fit for life as it exists on Earth, and for organisms of design and biology very similar to our own species. And secondly, to argue that this unique fitness of the laws of nature for life is entirely consistent with the older teleological concept that the cosmos is especially designed to hold with life and mankind as its primary goal and purpose. I did find, as I started looking at this, and I'd met Marco in Paris, and he gave me the fitness in '87. And 11 years later, this book was published. And I spent the next decade extensively looking for more and more evidence of fitness for beings of our biology and nature. And I found a lot more of additional evidence that, of course, wasn't in Henderson's Fitness, which was published in 1930. So basically, let's look at some of the evidences that nature is, as it were, fine-tuned for advanced organisms like ourselves. Well, we are terrestrial beings. And of course, there's many other terrestrial beings. We're also going to see that we use oxygen, and we get that by photosynthesis and such like. But first of all, consider nature's fitness for terrestrial life. Terrestrial life needs water, it needs minerals, and the plants need soils which retain water-retaining soils. And we need plants and trees because all animal life ultimately depends on eating the reduced carbons produced in plants. So you need water, you need minerals and soils. Well, of course, everybody in this room and everybody listening to this talk knows how the water and the minerals are delivered. It's by the so-called hydrological cycle. But what I think is not so well understood is that this cycle depends on the unique capacity of water to exist in three material states in ambient temperature conditions on Earth. It exists as a vapor, it exists as a liquid, and it exists as a solid. And these three material states exist over a temperature of about 100 degrees and over conditions which exist all over on the planet's surface. And everybody's aware of the fact that the water evaporates from the sea and condenses in the clouds and comes back as water to the sea, the hydrological cycle. But it does depend on this unique capacity. And water is the only substance on this planet which exists in three material states. Now, the story of the hydrological cycle, is much more extraordinary than just the fact that water exists in those three states. As the water returns to the sea, it erodes and leaches the essential minerals from the rocks, so that the fundamental property of water existing in three states gives us the cycle. But as the cycle turns, it now erodes those minerals from the rocks and distributes them into the terrestrial realm. really remarkable because this substance water not only gives us the hydrological cycle, but it has many properties which confer on it a unique and profound fitness in multiple ways for the erosion and weathering of rocks. For instance, water has a very high surface tension, so it goes into the cracks and then it expands on freezing, which aids in breaking down the rocks. It has a low viscosity, so it has mobility, and rapid running streams promote erosion of the rocks. And the low viscosity of ice aids erosion of mountains via glacial action. Ice has one of the lowest viscosities of any crystalline solid. There's another point about that, which I'll talk about later. And of course, water is the solvent par excellence, which aids in the leaching of essential minerals from the rocks and their distribution throughout the terrestrial hydrosphere. The formation of carbonic acid, where CO2 combines with water, further aids the chemical weathering of the rocks. So now you have a teleological hierarchy developing. You've got one unique property that exists in three material states, which gives you the water wheel. And now you find as the water wheel turns, as that water returns to the sea, it has a fantastic set of properties which are ideal for eroding the rocks. Now, just one thing about the mobility of water as a liquid and solid. It's basically both as a liquid and a solid erodes the rocks. But there's an interesting point about the fact that glaciers move, and the fact that if the mobility of ice prevents the buildup of permanent ice caps in the higher latitudes and higher altitudes. If in fact ice didn't move, in those parts of the world where the temperature is very, very seldom above freezing, such as the center of the Antarctic continent, for example, the ice would build up into massive depths of several miles and probably dehydrate the earth. And this is the nice little touch of fitness. The ice has to move as well. So every single feature of this remarkable system, it screams out design. I mean, you've got a teleological hierarchy of phenomena which make life on the land possible. And the other end product of erosion, of course, is soil. And it's no use if soil was just made of pebbles, where the water would just drain through the pores in the pebbles, and plant life would not be possible. It's only because, in fact, the end product of water erosion and weathering of the rocks is silts and sands, small, tiny particles of rock, and they, through surface tension, retain the water in the soils. So what you have in the terrestrial thing, you have an extraordinary teleological hierarchy of properties of water. The hydrological cycle depends on the unique capacity to exist in three material forms, and the erosion and weathering of rocks depends on another set of properties of water. The same substance which gives the wheel gives the erosion. I find this, amazing, an amazing fact. So we get the minerals of life, and we get soil, ideal water retaining medium for plant life. And this allows terrestrial life and animal life on continental surfaces like we have on the planet. That's one ensemble of fitness for beings, not exactly of our biology, but beings which share our biology in being terrestrial organisms. I wrote in The Wonder of Water, it is gratuity indeed that while water is serving the vital end of recycling the rocks, delivering life's matrix to land-based ecosystems, and enriching the global hydrosphere with the necessary elements of life, that those same tectonic and erosional abilities should create such magnificence. So the life-giving properties of the hydrological cycle and of the properties of water for eroding the rocks give us this. It's amazing. It's fantastic gratuity that this life-giving process should result in such magnificence as this. Okay, now let's turn to something else. Nature's fitness for oxidations. Just as terrestrial life is only of concern to basically terrestrial organisms, aquatic organisms don't need the hydrological cycle, but terrestrial organisms like us certainly do. Nature's fitness for oxidations only applies to those organisms which use oxidations and to generate metabolic energy, generate ATP. And nature's fitness for oxidation involves two things. It's the fitness for the generation of oxygen by oxygenic photosynthesis, and it's also fitness for the uptake and utilization of oxygen by biological systems for energy generation. Just to stress again, oxidation provides the metabolic energy for all complex organisms, including humans. Roman Bulatov called it the reaction that powers the world. I mean, it doesn't just power biological systems, it also has powered our industry since the beginning of this age of steam right through to today. It's passing away now, perhaps, into a new electronic era, but it was the reaction that powered the Industrial Revolution, and it's certainly the reaction which generates energy in living systems. We know how much energy oxidations release. If you live in Australia or California, places prone to forest fires, you're well aware of the enormous energy released by oxidations. Constant activity with advanced organs require great quantities of metabolic energy. And my own sort of area, the retina, fascinates me. The mammalian photoreceptor is capable of generating a measurable electrical response to a single photon of light. This remarkable capacity is dependent on a complex catalytic cascade consisting of a series of enzymes in the photoreceptor, which massively amplifies the initial signal. This amplification requires vast quantities of metabolic energy, and consequently, the photoreceptor layer has one of the highest metabolic rates of any known organ in the body. That's just to emphasize the essential nature of oxidation to generate the energy requirements of the body. And as you're sitting there now listening to this talk, you'd be amazed to be told, I think, that 1 cup of pure oxygen per minute is necessary to provide the energy you need even to sit at rest. 1 cup of pure oxygen. It's quite extraordinary. And if you're an Olympic athlete in vigorous exercise, you'll need 6 cups of pure oxygen per minute to provide the necessary energy. And the idea of that, it blows my mind that we need that much of the pure oxygen every minute just to sit on a seat. It's extraordinary. Now, oxygenic photosynthesis, as I'm sure most people here listening to this lecture will know, this is the vital process which involves the use of the energy of sunlight to draw electrons and protons from water, oxidizing it and releasing free oxygen into the atmosphere. The electrons and protons are then used to reduce carbon dioxide, generating reduced carbon compounds, including sugar. It's a very familiar reaction, and most people have some grasp of oxygenic photosynthesis and what it's about. But to understand just the teleological magic behind oxygenic photosynthesis, we must first consider the electromagnetic spectrum. This is of course, a vast range of wavelengths, stretching from gamma rays right up to radio waves. And the energy levels and the actual, the wavelengths here stretch over 25, 30 orders of magnitude. That's something one has to bear in mind. Now, the visible spectrum within this huge spread of electromagnetic radiation occupies a tiny region, an almost infinitesimal region in the electromagnetic spectrum. But this region, the visual region, which is light, has the right energy for photochemistry. George Wald, who worked for many years in the biochemistry of vision, he points out that almost all ordinary reactions involve energies of activation between 15 and 65 kilogram calories. This is equivalent energetically to radiation of wavelengths between 1,900 and 440 millimicrons. The energies required to break single covalent bonds, a process that through forming free radicals can be a potent means of chemical activation, almost all fall between 40 and 90 kilograms per mole, corresponding to radiation of wavelength 710 to 320 millimicrons. However one approaches the activation of molecules for chemical reactions, one enters a range of wavelengths that coincides approximately with the photobiological domain. I won't read this out, but basically, not only has light got the right energy for photochemistry, but radiation outside of the visual region is either dangerous when it's toward the UV end, or it hasn't got enough energy to activate atoms and molecules for chemistry if it's on the other side in the infrared, microwave, radio wave side. There's only one tiny region which has just the right energy for photochemistry. And so this is just emphasize one thing, that because most of these graphs are sort of logarithmic, they don't really convey just how tiny this visual region is. It's a very, very tiny region, the right energy for photochemistry. It's just in this tiny visual region. So what about the spectrum of solar radiation? And this is when the story becomes really magical. This is the spectrum of solar radiation. Guess what? The sun gives out most of its energy, radiative energy, in the visual region, and also in the infrared, and we'll talk about that in a minute. So what we have, an extraordinary fact, that the radiant output of the sun is concentrated almost entirely in the visual and near infrared regions. And that is that the sun puts out just the energy you need for photochemistry, for photosynthesis. The same tiny thing. So the cosmos, in a way, because our sun is in fact a pretty typical star, the cosmos is in a way flooded with the light of life. When you look out on a night away from city lights, and the cosmos is flooded with light. There's pinpoints of light everywhere. The great majority of stars are like the sun, putting out a lot of visual light. And there are some UV stars and other sorts of stars, but they're the great minority. The majority of stars put out the light for life throughout the universe. Well, it's one thing that the sun puts out just the right energy for photosynthesis, but that light now has to penetrate to the surface of the Earth if it's going to as it were, energize the chemical reactions involved in photosynthesis. It has to get through the atmosphere. And we find that it's, as one might start to predict now, from a universe that's ordered for life as we see it on Earth, and advanced life, advanced oxygen utilizing living things, visual light penetrates almost completely to the ground without any absorption. In the near infrared, that's the heat, there's absorption bands. And we'll come to that in a minute. This is an amazing, amazing bit of fitness in nature. Not only does the atmosphere let through the visual light right to the ground, it can promote photosynthesis. Just adjacent to that region of the electromagnetic spectrum, the infrared is absorbed. And if it wasn't absorbed, the temperature on the Earth would be 30 degrees less. On average, it would be way, way below zero. So that the absorption in the IR is also very important for life on Earth. And it's also vitally important that the visual goes right through the surface of the planet where it can promote photosynthesis. So now what we have is an accumulating set of coincidences. We now find that the radiation of utility for life is in the visual and near infrared. And the EM radiation, which penetrates the atmosphere, is in exactly that same place. So what about the absorptions of electromagnetic radiation by water? Once again, there's a window in the visual region. And amazingly, if you ask how far does light travel in the ocean, it travels down through water 1,000 meters, which of course is absolutely essential for life in the oceans. But it's also essential that water doesn't absorb visual light, because if it did, all cells contain water, and it would certainly be a problem in photosynthesis if light didn't penetrate through water. Well, there's a huge window in water. So we can say this again, same window. Now I want to just go back to the atmospheric absorption of visual and IR. This pattern here is precisely what you need for life on Earth. I've already said you need the visual to go down. Just imagine if that was reversed. If it was reversed life on Earth and certainly advanced oxygen utilizing organisms would not be possible. It's incredible. It's exactly what you want. And you know that you feel the heat on your hand from the sun. And that means that, in fact, some of the heat, the infrared radiation, is reaching the ground. But there's also quite a lot of absorption places where it's absorbed, and so that you can heat the Earth. So this is exactly what you want for life on Earth. You need the visual to go through, and you need absorption bands in the infrared. I'm running out of time, so I better keep going. I'll jump over that one. Now, one fascinating fact about photosynthesis and the atmosphere is that in the case of photosynthesis, 3 of the key atmospheric gases whose physical absorption properties are of such critical importance, letting through the light in enabling the process of photosynthesis to proceed, are also chemical players in the process of photosynthesis itself, which is a remarkable thing. And these gases aren't just peripheral players in the process, they are the major reactants. In other words, it's the 3 major reactants which ensure by their collective absorption properties in the atmosphere the availability of the vital light energy necessary to drive the reaction to completion. This is fitness on steroids. It is as if these 3 gases were colluding intelligently to promote their incorporation into the substance of a living matter. Therefore, the sun puts out just the radiation you need for photochemistry, and that radiation penetrates the atmosphere, and it penetrates water, and it penetrates through the gases, which are the chemical players in the process of photosynthesis itself. I rest my case. So what we have here is an extraordinary prior fitness, a magical prior fitness for photosynthesis, depending on a series of extraordinary coincidences. The radiation of utility for visual and adjacent near radiation of utility to life is in the visual and adjacent near IR, a tiny, tiny line in the vast range of electromagnetic radiation in the universe. And the output of radiation by the sun is in exactly the same thing. The atmosphere lets through this light to the surface of the Earth, and water lets it through as well. I mean, as I say, I rest my case. Here is clear evidence of fitness for oxygen utilizing organisms. This is the production of this is for the production of oxygen. Of course, there's another ensemble of fitness which allows you to utilize it. This is the remarkable fact that only regions of the spectrum allowed through the atmosphere, I'm rushing quickly now, is a tiny range of spectrum. In the Encyclopedia Britannica, the statement is made, considering the importance of visual sunlight for all aspects of terrestrial life, one cannot help being awed by the dramatically narrow window in the atmospheric absorption, and in the absorption spectrum of water. We should indeed be awed. And I love this quote by Sagan. Think of the sun's heat on your upturned face on a cloudless summer's day. Think how dangerous it is to gaze at the sun directly. What would we feel on its seething, self-luminous surface, or immersed in its heart of nuclear fire? The sun warms us and feeds us and permits us to see. It fecunded the earth. It is powerful beyond human experience. Birds greet the sunrise with an audible ecstasy. Even some one-celled organisms know to swim to the light. Our ancestors worshipped the sun, and they were far from foolish. One thing you have to say about Carl Sagan, he was a poet as well. Okay, now here is a remarkable thing. In the context of discussing, before I talk about the fitness of the utilization of oxygen, nature's fitness with utilization of oxygen, I've said something about the fitness for the generation of oxygen. Now I will, this is a sort of a little bit of a ad non sequitur really. It's about the fitness of nature for high acuity vision. But as we're talking about light and vision, it's perhaps appropriate to discuss it at this point in this talk. And this is a very remarkable thing. Vision, of course, is central to our being as humans. It's so important to our being as to understanding the world, to developing science, to doing this and doing that. So vision is a vitally important thing, and high acuity vision for us. And Aristotle was quite aware of this as well, as he writes in the first lines in Aristotle's Metaphysics: all men by nature desire to know. An indication of this is the light we take in our senses, and then he talks about the sense of sight. So, is there anything about visual light which is fit for high acuity vision? Yes, there is. First of all, just to remind you, visual light has the right energy for photochemistry. Photons of light are absorbed in rhodopsin and detected in the photoreceptors. So visual light has the right energy for photochemistry, for photodetection. But the image of the world around you is formed by waves. And this is part, of course, of the quantum weirdness, isn't it? I mean, basically, you detect light as particles or photons of light, but the image is generated by waveforms. So anyway, waveforms diffract when they pass through an aperture. The smaller the waves, the less they diffract. The larger the aperture, the less they diffract. You can see this by looking at harbors. You can looking at waves coming into harbors or into coves like this, as shown. So that the smaller the wave, the less it diffracts, and the larger the aperture, the less the waves diffract. Now, in the human eye, diffraction, the fact that when light passes through an aperture, it spreads out, diffracts, limits visual acuity. A point of light entering through the pupil spreads out, diffracts into a disc on the retina. The resolving power of the eye is determined by the size of this disc. It's called an airy disc. I think it's almost so intuitively self-obvious that the greater the degree of diffraction, the greater the size of this disc, this which was originally a point of light in the objective field, but on the retina it becomes a disc. So this is and the size of this disc determines the resolving power of the eye. Now, one of the fundamental formula here is the degree of diffraction, as I've already mentioned, is proportional to wavelength. So this is the visual region. When if the wavelength of light was larger, you'd have larger airy discs on the retina. If it was smaller, you'd have smaller airy discs. Let's consider first of all if the wavelength of light was greater than it is, say 10 or 5 times greater, then the only way to compensate for this, to recover the visual acuity of the human eye, would be to increase the aperture and have to make a bigger eye. The problem with that is that, in fact, while the eye at the moment is commensurate with our basic design, if the wavelength of light was bigger than it is, say 10 or 20 times bigger, you'd have to have a far bigger eye with a much bigger pupil aperture to get the same visual acuity. And clearly that's not, how big would you want to go? If the wavelength was a lot longer, you'd have to have a gigantic eye to rescue the high visual acuity of the human eye. But if the wavelength was shorter, then there's a problem, because in fact designing photoreceptors, which would be smaller than the current ones, is very difficult to imagine. Currently, photoreceptors contain 150 million light-absorbing molecules, and this number is necessary for function in dim light to detect a single photon. And it's also essential if you want to detect millions of charge, you need millions of charge receptors to see in bright light. So it's very difficult to imagine how you could make the photoreceptors narrower. As it is at the moment, the tip of the photoreceptor is between 1 and 2 microns in diameter. It's very small. So therefore, if the wavelength of light was shorter than it was, I don't think you couldn't get much advantage, minimal advantage of anything, because you can't reduce the size. There's a biological constraint. You can't reduce the size, the diameter of the photoreceptors. If it was longer than it was, to recover and to rescue the same visual acuity you have in the human eye, you'd have to increase the aperture. You have to make a much bigger eye. So it turns out that the wavelength of light, and this I think is an absolutely amazing fact. The visual light, the photons of visual light have the right energy for photo detection, and they have the right wavelength to give high visual acuity in an optical device of about the size of the eye. I've simplified this a bit, I haven't gone into all the details, but the sum is this: the wavelength of light is fit for high acuity vision in an eye of size commensurate with our biological organisms, with biological organisms of our size. But I think this is an amazing fact. So the visual region is fit for photosynthesis and high acuity vision. Photosynthesis also makes possible the high metabolic rates necessary for the existence of advanced organisms and for high acuity vision. So it's just right for eyes of our size and so forth. So now we can add another tier to our coincidences: nature's fitness for beings of our biological design. I really have to rest my case, it's magical. There's a whole series of coincidences, including the final one, which is in fact to have a high acuity visual device commensurate with the size of our body. You have to have the properties of light have to be exactly as they are. Has to be ideal for photo detection and for generating a high quality image on the retina. Now, what about nature's fitness? I hope I'm not going on too long here, actually. I think I've talked for nearly an hour now. I'll just say some more words about nature's fitness for the uptake and utilization of oxygen in our biological systems, okay? Once again, just to remind you, our oxygen requirement is 1 cup of pure oxygen per minute to provide the necessary energy we need even at rest. Now, to take that much oxygen out of an atmosphere requires an atmosphere that's highly enriched in oxygen. And the current Earth's atmosphere contains about 20% of oxygen. But I think we mentioned earlier that when oxygen combines with reduced carbon compounds, whether it's in a forest fire or even in the body, it reduces vast amounts of energy. So the question arises, and was asked by Arthur C. Clarke, given the enormous vigor of oxygen, its extraordinary reactivity and the energy it generates when in oxidations, how come we don't have spontaneous human combustion? Clarke said in a TV series, there's one mystery I'm asked about more than any other: spontaneous human combustion. Some cases seem to defy explanation and leave me with a creepy and very unscientific feeling. If there's anything more to the spontaneous human combustion, I simply don't want to know. Well, Clarke can rest. We can all rest, because oxygen, for some reason, I think it's obviously again another element of fitness and teleology in nature, oxygen is relatively unreactive below 50 degrees centigrade. Dioxygen, the form of oxygen at ambient temperatures, is relatively unreactive. This is because of an energy barrier which must be overcome to convert the dioxygen into a variety of several higher energy species of molecular oxygen, in which all the electron spins are paired, is much more reactive towards common organic molecules. So basically, there's a thing called spin restriction, which as it were, makes oxygen reluctant to act at ambient temperatures, the temperatures of biological systems. And because oxygen is relatively inert below 50 degrees centigrade, as we all know, lighting a campfire is often quite hard to start. And this reluctance to react saves us ultimately from spontaneous combustion. Oxygen is relatively unreactive at body temperatures. So that raises, of course, a question, because if oxygen is unreactive at body temperatures, how come it can be used in biological systems? Well, it can be used in biological systems because, as Nick Lane points out, there are two ways out of the chemical cul-de-sac. First, oxygen can absorb energy from other molecules that have been excited by heat or light. That's the campfire. Once the campfire is going, the heat of the fire activates the oxygen and the fire becomes self-sustaining. But there's another way, the second way of coaxing, oxygen to react is to feed it with electrons one at a time, so that each of the unpaired electrons in the oxygen atom receives a partner independently. Then Lane continues, the transitional metal atoms like iron and copper have the ability to do it. Iron, for example, can denote one electron at a time and commence the activation of oxygen because it has its own unpaired electrons. This is quite complex physical chemistry, of course, but nonetheless, what this means is that nature has provided further evidence of the fitness of nature for the use of oxygen with a set of transition metal atoms that are fit to activate oxygen. And so basically, we are protected by oxygen's reluctance to act from spontaneous combustion. And in the body, however, there's a set of elements, iron and copper particularly, which are able to activate oxygen in a controlled fashion in the body. So this is, once again, another element of fitness, and it's an element of fitness which is particularly relevant to oxygen-utilizing organisms. Now, final at the moment, there's many other elements of fitness which, of course, I can't cover. Are covered in Nature's Destiny and covered in other books that I've written. But another very important element of atmospheric fitness for the use of oxygen is that nitrogen is an excellent fire retardant. And so although the attenuation of the activity of oxygen through the spin restriction, through its reluctance to act at low temperatures, makes fire hard to start, once alight, the heat generated activates oxygen and the fire begins. The speed of spread is slowed because of the presence of nitrogen, which is a powerful retardant, having a high specific heat, which soaks up the heat surrounding the flame and slows the rate of fire spread. So that when a fire starts, because of the heat activates the oxygen, it becomes self-sustaining. And it would spread catastrophically if it wasn't for a major retardant in the atmosphere, which slows greatly the spread of the flames. And so here is another element of fitness for our use of oxygen and for our coexistence with this dangerous compound in the current atmosphere of the Earth. Now, just a few words about additional fitness. All these elements of fitness we've been talking about, from sunlight, from the various elements of fitness which allow the generation of oxygen through photosynthesis, and those elements which allow us to live with an oxygen-enriched atmosphere and to utilize it in the body. We, of course, have to actually take air into the body to extract the oxygen. And when we look at there's another ensemble of fitness for breathing. Air has a low density, it has a low viscosity, so it can be taken in and out of the body in the lungs. It can be breathed in and out. If air had the density and viscosity of water, it would be almost impossible to take it from the atmosphere. So the low viscosity, the low density of air makes breathing possible. In fact, basically, it's interesting to know that what the effect of density is. The maximum voluntary ventilation is approximately proportional to the reciprocal of the square root of the density. This means that at depth of 30 meters, 4 bar, the maximum voluntary ventilation is only 50% of what's at sea level. Well, one can imagine the difficulties of breathing if air had a much higher density and viscosity. So here's another element of fitness. Nature is fit for us to take the oxygen from the atmosphere down to the alveolar and into the blood, and for distribution in the body. Now, there's another terminal, we've already mentioned it, Henderson mentioned it in the fitness. There's a final terminal element of fitness, which is the gaseous nature of CO2, which I've already mentioned, was mentioned by Henderson. Oxygen combines with reduced carbon compounds in the body, and the two waste products are water and carbon dioxide. Now, if carbon dioxide was an innocuous compound, if it was noxious, if it was not a gas, if it was a solid or anything else, this would be impossible. All the fitness we've discussed would be irrelevant, would be to no avail. Because when you oxidize reduced carbon compounds in the body, a compound is produced which you can't get rid of. And as Henderson said, I'm quoting him again, it is difficult to imagine by what elaborate chemical and physical devices the body could rid itself of such enormous quantities of material, were it not for the fact that in the lungs, carbon dioxide can escape into the air, which is charged with but little of the gas. Were carbon dioxide not gaseous, its excretion would be the greatest of physiological tasks. Were it not freely soluble, a host of the most universal physiological processes would be impossible. So here at the very end of the oxygen saga is a fantastic element of fitness that CO2 is an innocuous, harmless gas which can be breathed out of the body. I rest my case. So let's look at the fitness of nature for air-breathing terrestrial organisms. First of all, there's the fitness of the hydrological cycle, which is indeed very remarkable. As we see, it involves a hierarchy of properties. There's the fitness of sunlight for photochemistry and photosynthesis. There's the fitness of the atmosphere for the transmission of visual light and the absorbance of heat necessary to raise the temperature of the Earth about 30 degrees centigrade, which gives you an average temperature on the planet of about 15 centigrade. There's the fitness of the wavelength of light for high acuity vision. And high acuity vision, as I've mentioned, and as Aristotle saw, is a major feature of our biology. And particularly extraordinary is that, in fact, the high visual device with high visual acuity is commensurate with the being of our biology and size. Then there's the relatively low reactivity of oxygen ambient temperatures, which prevents spontaneous combustion of reduced carbon compounds. There's the existence of a fire retardant, nitrogen, which slows the spread of fire. There's a low density and viscosity of air, which enables the work of breathing. The properties of the transitional metals allow the controlled handling and activation of the body. And then finally, the gaseous nature of CO2 enables its excretion in the lungs. So indeed, you could say the medieval scholars were actually correct. There is a connection between our biology and the cosmos, between man and nature, between biology and cosmology and so forth. And from the evidence I've presented here, and there's a lot more I could actually present, but I think that I've spoken for more than an hour, and I think, in fact, this is a huge topic. I mean, one can go through a vast number of other elements of fitness in nature for our being. But these ones I've touched on now, I think, are sufficient to show that the fine-tuning of nature is not just the cosmological fine-tuning. It's not just for stable planets, for suns which last for billions of years, and so forth, for stable galaxies. It's also for biology, and not just generic biology, but the biology of beings like ourselves. And so I see this extraordinary thing, because what it sort of means is that at the beginning of the scientific revolution, we lost our place in nature, effectively. There was no connection between biology and cosmology, between man and the cosmos. But since about the late 19th century, with the discoveries in biochemistry and respiratory physiology, and then subsequently with the discovery of the nature of photosynthesis and so forth, and tectonic recycling, this kind of slowly but surely we're recovering the fact that indeed nature is fine-tuned for beings like us, and we do occupy a very important place in the order of things. So we are sort of recovering the medieval conception that in the depths of nature, man finds himself. And that's what I tried to bring out in Nature's Destiny, and in the recent monographs I did with the Discovery Institute. In the depths of nature, man finds himself. And this, I think, is, in its way, it's interesting that, in fact, Davis, Hoyle, and then recently Hugh Barnes, they can argue for the existence of a creator from the fine-tuning. But from this evidence, you can argue that the creator intended us to be here. What Freeman Dyson said, the universe must have known we were coming. So this evidence puts man back in the picture as a purposeful end of nature itself. And also, by the way, I must say that, in fact, although I haven't stressed design here, if you wanted evidence for design in nature, you couldn't go beyond the hydrological cycle and some of the other things I've mentioned. Those coincidences, the list of coincidences which underlie photosynthesis and the utilization of oxygen. Well, I think I don't know whether, probably, I don't know, I'm falling asleep or whether the audience has fell asleep, but I think I'll bring this talk to a close now. There's only one point I missed because I'm at 3 o'clock in the morning, I think. I showed a beautiful figure earlier in the talk, which was from Fabrica. I think it was the first Muslim man. And if you look at that, if you go to Fabrica and have a look at it, it's wonderful. Fabrica is wonderful Renaissance art. In that beautiful picture of the first Muslim man, he's looking, the head looks up to the sky in puzzlement about the nature of our being. And he's walking forward. It's amazing. He's actually walking forward. He's walking from the closed, comfortable, secure world of the Middle Ages into the new scientific world that was opening up in the 16th century. It's an amazing picture. And I think now we know that he doesn't need to be so troubled. He was troubled with the evidence that was available in 1543. But the evidence available now in the 21st century suggests very strongly that the universe has been fine-tuned for beings of our biology. So I think I should now, I keep on saying I'm going to wrap up, but I think I should stop now before I fall asleep. And I hope you've followed what I've said. I've talked probably too fast and gone through a whole lot of evidence, perhaps too quickly. But I think I should call it a day now. Are you there, David?
I am here, Mike. Yeah, I can be the first to say thank you ever so much for a fantastic talk. That was it was gripping from start to finish, and it's one of those talks where you just know you've got to go back and listen to it several times to go through each of the points you've raised, because it seems to me that each of the points you raise is a talk in and of itself on the detail.
Yeah, my attention span at the moment, and I suppose it's the low point of the circadian rhythm. I sort of, Anyway, basically, there's no doubt that in fact I missed some points. I should have stressed that's the.
Well, we might pick them up. We might pick them up in the Q&A.
Okay.
So if it comes to you, but let me kick it off with this one. You talked about over the years and the details of history in your talk. The question came in: if Darwin knew all of this, do you think he would have developed his theory?
That's a very, very interesting question. My suspicion is the reception of Darwinism would have been far less. I think he may have still proposed his theory, but I think the cultural environment would have been very different. It would have been very different, because this evidence, what the evidence I've talked about at the moment, doesn't say how life arose or how the bacterial flagellum arose. It's about the fitness which enables things to occur in the biological realm. It's an enabling fitness, a deep enabling fitness in nature for our being. It doesn't tell you. You can make a very powerful argument. The various adaptations came about by design, and I think that's the explanation. But that's not what I'm talking about here. So if Darwin had this background, though. For instance, this fitness evidence for design provides, in a sense, an independent line of evidence that specific adaptations are here by design. It's like an independent line of evidence. For instance, if you see that the nature's arranged for a device like the eye, capable of very high visual acuity, high resolution, then it suggests, I mean, that's a pre-design in nature for the eye itself. So if you come along and argue that the eye is there by design, it's sort of backing it up. It's like an independent line of evidence. That's what's so important about the fitness. That it's a completely independent line of evidence about design for biological systems in nature. So it backs up the whole ID scenario completely from a different angle. 99% of ID is focused on adaptation or gaps in the fossil record and all these sorts of things. But this is a totally different line of evidence, which backs it up. And that's what I find. So I think that, yes, I think that Darwin would have been perhaps more hesitant, I don't know, if he'd known this evidence. My own prediction is that in the end, the ID argument is going to win through. Because basically, I mean, if you take the origin of the genetic code, the origin of life problem, a coding system is the very hallmark of intelligent agency, you know. And in the whole of my academic life, I've been hearing that the problem of the origin of life is going to be solved in the Darwinian, you know, paradigm. I heard this in the 60s, I heard this in the 70s, I heard this in the 80s, the 90s, and now here we are in 2021, and there's still no solution. And I tell you one thing, the origin of life will never be solved outside of a teleological framework. That's, you know, for sure. And so, and I also believe in the rationality of humans in the end. I mean, we're a pretty crazy species, but still we do have we do adhere to some rationality. And I think in the end, some of these ID arguments, particularly the origin of the code, can't have come about without some form of teleology, without some sort of direction and design. Eventually is going to win through, you know? And I think you're going to see, perhaps in the next decade, they're going to say, you know, these crazy guys at the Discovery Institute, these crazy sort of people, you know what? They had a point. And they've got a point. And the importance of the Discovery Institute, and also guys like you, is this, that this has been a scholarly attempt to criticize Darwinism, a serious scholarly attempt to criticize Darwinism. And in the end, such critiques will win through because they're actually right in the end. And so my prediction is, I may not be here to see it, but my prediction is over the next decade or so, there will be some major concession in mainstream biology that these crazy guys at the Discovery Institute had a point all along. Anyway, sorry.
That's all right. Let me move on. I'm going to say hello to some friends of ours because we've got some regular viewers in Scandinavia. So they were very excited to know that you were doing a talk and actually filed a question in advance. So I'm going to go straight to the talk from our question from our Scandinavian
This is getting
friends.
scary.
And it's this. Would you, I'll start off with thank you, actually. They say, thank you for writing The Miracle of the Cell, one of the most inspiring books I've ever read. And then the question goes on, would you say that the elements from the periodic table you mentioned in the book, like carbon, iron, oxygen, etc., look suspiciously like they were created as specific building blocks for life? And could our opponents rightfully argue that nature just managed to get the best results from what was randomly available?
Well, I think the fitness of the elements for the carbon-based cell is certainly correct. Yes, that fitness enabled the existence of the cell. Without that fitness, you couldn't have a carbon-based cell. And my suspicion is there's no other ensemble of elements in the periodic table which can give you any other form of biochemical life. But certainly the fitness of those elements gives you the basic building blocks, which allows you to build the cell. What was the second thing again?
Can our opponents argue that nature just managed to get the best result from what was randomly available?
Well, I mean, that's always the argument against something you claim it's designed to say, well, it's just chance. I mean, for all the evidence I've presented here, somebody could come along and say, well, it's all just a huge fluke. It's all just a vast set of coincidences, which wasn't purposed by any intelligence or anything. It's just a fluke. And so an opponent can always say, you can always oppose design by saying it's just chance. It's amazing. Yeah, they can say it's an amazing design, but it's just chance. Just chance. I mean, I reject that inference, but I think you can make that inference if you want. Isn't that correct? You could make it. It's an alternative.
Yeah. Can I ask?
Yeah.
Can I ask why you reject it?
Why I reject it? Well, it's because, in fact, basically, it's the combination of the beautiful elegance and parsimony of the whole thing. I can sort of feel when I look at the evidence I've presented here, like the hydrological cycle, the use of oxygen, and the coincidences in sunlight and the size of. Then of course, there's the beauty of the scenery generated by the hydrological cycle. I mean, it's a whole mix of things. And it strikes me as being, well, yes, you could say it's all just chance. Okay. But for me, it's like ludicrously improbable that such a thing would ever happen without direction or design. That's all I can say. I mean, I can't quantitate it, but subjectively, to me, it's ludicrously improbable that that could be the case.
Okay. David, could I just intervene in that for a moment? Michael, thanks for your talk. It's brilliant. On that question of chance, surely it could be argued that it is profoundly unscientific to attribute to chance the kind of complexity that you've been describing this evening. I mean, scientists wouldn't normally resort to that kind of explanation unless there was a kind of philosophical compulsion to do so.
Yeah. Yeah, 100% agree with you. Yeah, I mean, basically, that's right. Yes, I mean, normal science would look for an explanation for such phenomena rather than just say it's chance. Because if you say it's chance, in a sense, that stops science. You don't investigate any further. Yes, I agree with you. But all I'm saying is that, in fact, logically speaking, there is the possibility that it is chance. Logically, yeah. But not science. But in terms of sensible inference, that doesn't make any sense to me. But I do acknowledge that somebody can come along and say, well, that's just chance.
I'm going to need to give that.
What you say, I agree with you. Yeah.
I'm going to need to give that some thought, Michael. I think that's the first time I've heard someone say that attributing it simply to chance stops science, because that's almost always the criticism that is put at creationists or intelligent design proponents. As soon as you bring in some sort of intelligent or supernatural being, then you stop science. But interestingly, I can see the argument that attributing something simply to chance also stops science.
Yeah, I mean, if you said the universe, if you take the cosmic constants that the physicists and the cosmologists talk about, if you said, well, it's just chance, then you wouldn't investigate any further aspects of the cosmos to see if it was chance. Yeah, that's right. Yeah. So, yeah. Okay. I don't think I'm the first person to say that, though.
I suspect I know the answer to this one then, given your skepticism of chance here, and it's this. The questioner starts with, thanks for a great talk, Michael, and then asks, what do you think are the chances of finding that extraordinary set of conditions for life on an exoplanet anywhere in the universe?
Well, I wouldn't say. No, this is an interesting question. The Earth certainly is a very remarkable planet. There's no doubt about that. Whether it's actually unique or whether there's no other Earth-like planet in the universe, which is what is you'd have to assert. I think that would be at the moment. I think that would be an unscientific statement. I mean, basically, we have to find out more about the formation of planets, more about how likely it is to get a tectonic system, how likely it is to have the nitrogen in the atmosphere and things like this. We don't really know. I suspect, given the size of the universe, though, that there must be other planets out there which are approximately like the Earth. Whether they're exactly like the Earth or not, I don't know. But it might certainly turn out that the Earth is absolutely unique. This is a possibility, But at the moment, I don't think we know how unique it is. I suspect this is a non-scientific suspicion of mine that it's probably turned out that we are the only highly intelligent beings in the cosmos, the only beings that can understand it and come to terms with it. And probably the Earth is perhaps a unique planet. And I know there's some people in the ID community that would argue this, but I'm open to the possibility that there could be other planets very like the Earth. Does that answer the question? Yeah, I'm open to that.
Yeah, okay. Let me move on to another one. It says this: you have said several times, "I rest my case." And then the question is, how do you describe the logic of your case? Does your case have to include the rejection of evolutionary gradualism?
As far as the fitness element's concerned, as I say, it's a whole different argument to causation, the causation of evolution. What is the cause of a bacterial flagellum? What is the cause of the first cell? That's what you might call proximate causation. What we're talking about here is prior causation, before these things even occur. In other words, it's setting the scene. It's rather like, setting the stage for Hamlet so that the drama can proceed. So it's a totally different thing. So, I mean, you can't, evolution, from the evidence I presented, you could imagine special creationism, you could have progressive creationism, you could have even Darwinism. And the evidence I'm presenting would still stand, that the universe was ordered for the existence of life and for man, cells and things like this, was ordered for their existence, to enable their existence. And the actual proximate causation of how they came about, whether it was special creation or Lamarckianism or some other form of model of evolution, is really irrelevant to what the argument that I'm presenting is. This is an argument to enable things to happen.
Okay.
Yeah.
Let me take that back a step. I'm going to adopt your Hamlet analogy. If that effectively you're building a stage which enables then Hamlet to take place, and that may be by Darwinian means or whatever, how do you build the stage? Can the stage be built in gradual steps or not?
Well, it's all the laws of nature that I've been discussing here, presumably were born, if the Big Bang theory is correct, and the universe exploded into existence 14 billion years ago, then at that moment in time, all the laws were fixed instantaneously together. This is the biggest saltation you can conceive of, right? The whole thing was put together instantly in the moment of creation itself, because the laws of nature are universal and well, I better be careful because physics is moving in strange directions these days. I mean, quantum mechanics is strange enough as it is. And I was going to say the laws of nature are always the same everywhere in the universe. Well, of course, some physicists might question that as well. But on the whole, I think you can say that, in fact, the evidence that I'm discussing didn't come about gradually. It was all there at once, in the moment of creation itself. And so therefore, when Dyson said the universe knew we were coming, I think he was dead correct, because there was a primal blueprint for our being at the very moment of creation itself. Yeah.
Okay. You talked about Henderson.
Yeah.
Where would you place Henderson in his beliefs? And as the questioner asks, was he a great critic of Darwinism?
Yes, he certainly was. He certainly was a critic. I don't have the quotes right in front of me, but yes, what he said was that evolutionary biology ignores the topic of fitness. He could see this, and so he's a critic of Darwinism and the biological establishment to the extent that he criticized their sort of rejection, the disinterest in the topic of fitness, because as he said, biologists are interested in how organisms are fit to the environment, but never how the environment is fit for organisms. What I've been talking about here, of course, is the fitness of the environment for organisms, whereas Darwinism and most evolutionary theories explain how organisms became fit or adapted to the environment. So it's an inverse sort of thing. And he points this out in the preface to Fitness and also in the conclusion. So he does criticize Darwinism to the extent that the Darwinian establishment ignore fitness. See, and I think the reason for that is that, in fact, and mind you, it's an absolutely amazing thing. In preparing my next book, Primal Blueprint, I had to read through a whole lot of stuff about how land plants evolved, how endothermy evolved, and this sort of thing. And it's amazing. You can look at all the accounts of how life adapted to the land, to the terrestrial sphere. You know, how amphibia crawl out in the Devonian swamps, how plants colonize the land and so forth. And there's not one single mention of the hydrological cycle which enabled those events to occur. It's the same as endothermy. There's a huge literature about how endothermy arose. And yet, if you look at that literature, I haven't found one paper yet. I might find it eventually, because I mean, there's a huge literature out there, but I haven't found one paper yet that mentions the specific heat of water or the evaporative cooling of water, which is critical to endothermy. In, you know, for instance, specific heat is specifically, it means that in fact it's much easier to maintain your temperature at a constant level because the specific heat of water is one of the highest of common fluids, right? Then if you're in the tropics, if you can't get rid of heat by evaporation of water and you want to maintain a high body temperature, take away the evaporative cooling of water and you're dead in about 6 hours, right? You know, so, you know, because your body overheats. And yet none of these papers mention this. And the evolution of the lungs, nobody mentions or the evolution of oxidative metabolism. Nobody mentions the underlying fitness which allows these great advances to occur. It's absolutely dramatic. It's a huge blind spot. And so Henderson does mention that blind spot, that biologists are not conceding that all the basic advances in evolution require an immense fitness, or let's put it more brutally, design in nature for those advances to occur.
Okay, I've got 2 questions for you, unless someone quickly gets a question in on the live chat. First question is, you've teed me up for it there without realizing it, so I'll ask you, when does the book come out?
Oh, heavens above. I've had a well, I was trying to get Primal Blueprint finished, a manuscript finished by sort of, you know, late July. But what with having my car stolen, having, you know, credit cards stolen, and also finding it, the isolation here in Perth is getting difficult to take. I know that, you know, and I think I'm the wrong age group for Zooms and things. You know, I prefer live audience. When you give a talk, you want to seduce the audience, really. If there's no audience there, it's sort of peculiar. It's like abstract, you know. There's no echo. There's no sort of to and fro. And my daughter also, one of my daughters lives in Austria, and she's also a writer as well, and she writes all sorts of books. And I was talking to her on email on Skype yesterday actually. She was saying how her creativity is starting to go down with the imprisonment and the lockdown situation, just losing social contact, which invigorates us all. And I'm losing social contact in Perth. And I never worked in Perth. I never had an academic position here. I've just got family here. And I came to Perth at the beginning of this damn pandemic thing, and I got stuck here. And now the Australian government won't allow you to leave Australia. And they're saying until into next year. So that's, yeah. Just because they're worried about the existence of more noxious strains, right, starting to spread. But I found it, so I have found that my creativity has not been what it was. Whether it's aging or whatever it is, or whether it's the pandemic, I don't know.
So are we hopeful for later this year?
Sorry?
Hopeful for later this year with the book?
Hopefully for later this year, yeah.
Okay. I don't know, that might, the answer might be that it'll be in that book, but here's the final question from online. You mentioned thousands of standalone examples of natural phenomena even, that couldn't have come about by Darwinian gradualism. I would love to find a book that presents even 100. Is there such a compilation?
Well, basically, you can take Henderson's classic fitness, or you can take Alfred Russel Wallace. See, Alfred Russel Wallace was a contemporary of Henderson. And of course, in the world of life, he also, I probably should have mentioned Wallace as well, but Henderson's book is a far more focused, presentation of fitness than Wallace's world of life. But Wallace does make the same points. So Wallace, Henderson, there's many papers by George Wald, as well, who was the Nobel laureate who worked out how vision occurs. And then there's my book, Nature's Destiny. And all these books present the fitness evidence. And I think they show that you can't get this stuff gradually. You can't get the properties of oxygen gradually. You can't get the properties of water gradually. These are givens of physics. And they were given at the moment of the Big Bang, and they're not changed. So I'm fascinated in this idea that, in fact, the sort of the designs of nature in the laws of nature might be approached gradually, because that I don't get that, actually. I mean, what we're talking about here is universals, eternal universals in the nature of things. Yeah. So anyway, that's all I can say. Yeah.
Well, Mark, I will finish how I started this by saying thank you ever so much. It's been a fascinating talk and a fascinating Q&A, and thank you, double thanks to you for doing it in the middle of the night. So we are very grateful to you. I'm going to hand back to David Galloway, who I'm sure will continue with thanks on our behalf.
Next time you go to a library, get Andrea Vesalius's book De Fabrica and have a look at the actual anatomical drawings in there. It's the high noon of the Italian Renaissance, and it's great art. Every single thing is a fantastic art, and a lot of it captures, as I said earlier, and I wish I mentioned this in the talk actually, it captures the excitement, the puzzlement, the strangeness of the moving from the closed world of medieval Christianity into the new scientific era. And you know what I think? When I first saw this as a medical student, I was impressed. Before I got into all this, I was still impressed by it. It was beautiful and wonderful stuff, wonderful drawings. And it seems to me that the destiny of science was to rediscover, as it were, our place in nature, the centrality of man in nature, to reverse the Copernican sort of revolution, to put man back in the center of things. And the tragedy was that in the first 3 centuries of science didn't discover these connections. It's only since the late 19th century and onward today that we rediscovered these connections. But I do believe that, in fact, the birth of science was, in fact, it's sort of fateful. It's man's fate. Our fate was to rediscover that, in fact, the universe did know we were coming. Yeah, I'm sure that's a firm belief of mine. It's yeah.
Good, Mike.
Anyway, okay,
Thank
David.
you very much for that today. Really, I mean, I think, what can I say? The evidence that you presented of foresight and intentionality, the way you've rounded that out just in these final few moments. Actually, when you're speaking about Vesalius De Fabrica, it struck me that he used his writing, and he was only 29, when he published that.
Yes, I know. Amazing.
Yeah.
Yes.
But when he was applying for a post as a physician to the Holy Roman Emperor at the time, Henry V of Spain, he actually used, as part of his CV, a hand-colored copy of the Fabrica. Fabrica. And he got the job, actually, which is also interesting. But let me also just say this. I mean, I think your writing has really added a real sense of credibility to the argument that you've given us this evening. So thank you very much for what you've done tonight. It really was a formidable lecture, awesome in many respects, outstanding and eye-opening, and we're deeply grateful to you. And I wish you well with the Primal Blueprint when it finally years later this year. I think we should let you get off to bed, given that it's goodness knows what time there, 4 o'clock in the morning or whatever.
Yeah.
But let me say that this lecture will be available on our YouTube channel, and we'll be linking to it on the website. Let me encourage you folks to register on the website, make sure that you're up to date with all your contact details, and hit that bell on the YouTube channel so that you don't miss any of the upcoming content. Just as a final point, and it's this, as we bid goodnight to Mike and to the rest of you, our next event is going to be on the 14th of June, and will feature Steve Meyer, who has just released his new book, The Return of the God Hypothesis. 14th of June, we'll be sending out an email in the usual way. But for now, thank you very much, everyone. We'll bid you good night. And Mike, once again, thank you most sincerely for your contribution today.
So yeah, I hope I didn't lose concentration a bit. I mean, anyway. Okay. Yeah.
So the live stream will go down now, and if you just stay on the line for 2 minutes, we'll be